Alrighty, in this lesson we are going to be learning about completing the square. At the end of this lesson, you will be able to create a perfect square trinomial using completing the square, and you'll be able to evaluate an inverse trig integral by completing the square. Alrighty, so first of all, before we evaluate an inverse trig functional using completing the square, we need to learn how to do it. Okay, the quadratic trinomial x squared plus 6x plus 9 can be factored as x plus 3 times x plus 3 because it's what is called a perfect square. And you'll notice this is really x plus 3 squared. So that is a perfect square trinomial. So how do you factor a trinomial when it isn't a perfect square? We are going to make it one. All right, so this says let's create a perfect square trinomial out of the trinomial x squared plus 6x minus 7. Notice at this point in time, this trinomial cannot even factor. So we're going to turn it into one that can be factored, and it is actually a perfect square. So what we are going to do, this is a process that you will always use. We are going to put x squared plus 6x, then we're going to leave a blank on the inside. So we're going to be putting something there, and then we'll just put that minus 7 on the outside. All right, so now if we're thinking about how am I going to make this into a perfect square trinomial, we're going to take the middle term, and we're going to divide it by 2. 6 divided by 2 is 3. And then we're going to square that number. So 3 squared is 9. So we are going to put plus 9 on the inside. And we're not just allowed to put a plus 9 in a problem because it would change the value of the problem. So in order to undo the plus 9 on the outside of the parentheses, we'll do a minus 9. So if I were to get rid of the parentheses, that really just still would be x squared plus 6x minus 7. So now x squared plus 6x plus 9 is a perfect square trinomial. It would factor as x plus 3 times x plus 3, but we will write it as x plus 3 squared. And then minus 7 minus 9 would be minus 16. Please note that when we find this number right here, it is always the number that we got when we divided it by 2. So now I'm going to let you try one. Please create a perfect square trinomial out of the trinomial below. Please pause the video, try it, and then come back and see how you did. Alrighty, welcome back. The first thing that we want to do, of course, is we're going to do x squared minus 4x. We'll leave ourselves a space, and we'll put minus 9 on the outside. All right, so the first thing we're going to do is take this negative 4. We're going to divide it by 2, which gives us negative 2. And then we are going to square negative 2. Negative 2 squared is a positive 4. So we're going to put plus 4 on the inside, and we will undo it by putting a minus 4 on the outside. So now x squared minus 4x plus 4 is the perfect square trinomial x minus 2 squared. And again, I got that minus 2 the fast way by it is whatever you get after you divide by 2. So it'll be x minus 2 squared, and then minus 9 minus 4 is minus 13. Please notice in this case, instead of getting plus, we got minus because when you divide negative 4 by 2, you do get negative 2. All right, now we are going to be using completing the square with inverse trig integrals, which you learned in a previous lesson. So if I look at this, the reason that I know that I would want to complete the square with this, if you looked at it, first of all, we don't know how to take the integral of it. It's not one that I could do a u substitution with, because if I let u be the denominator, du would not be there. We don't have a 2x minus 2 hanging in our problem, so we're pretty much stuck. So I notice that it's a trinomial, which means it's probably a pretty good candidate for completing the square. So that is what I'm going to do. I'm going to do x squared minus 2x, leave myself a blank, and then put plus 6. All right, completing the square, we'll take that negative 2 divided by 2. That will give me negative 1. And then I'll square that. Negative 1 squared is a positive 1, so plus 1 will go on the inside, and minus 1 will go on the outside. So when I go to rewrite this problem, I have dx over x squared minus 2x plus 1 will factor into x minus 1 squared plus 5. All right, now I notice if you're thinking about inverse trig, this looks like the setup for arctan because of the plus sign. So I'm going to identify my parts. My u will be the x minus 1. And notice we're used to having this written as a squared plus u squared. It really doesn't matter the order because addition is commutative. My du will be 1 dx, which is there. And then my a, 5 is a squared, so a will be the square root of 5. So now I am set to use my arctan formula, which is 1 over a, so it's going to be 1 over square root of 5, arctan u over a plus c, and there we go. All right, problem number 2. If you would like to pause the video and try this one, that would be awesome. So I'll let you do that and come back when you're done. All right, this is another candidate, again, for completing the square because I notice I have a trinomial down here, and doing a u substitution is not going to help me take the integral of it. So I am going to get it set up for my perfect square trinomial here. Okay, I will divide by 2. That will give me 2. If I square that, I will get positive 4. So plus 4 minus 4. And then from here, I'm going to rewrite my integral. This will factor as x plus 2 squared plus 3. And then once again, I notice the setup of that is, again, arctan a squared plus u squared, or u squared plus a squared. So I'm going to identify my parts. My u will be x plus 2. My du, the derivative of x plus 2, is just 1 dx, which is already there. Oops, there was a dx in there at one point in time. And then my a, since a squared is 3, a is going to be the square root of 3. Now I'm just ready to go ahead and use my arctan formula, which is 1 over a. Arctan u over a plus c, and that will do it. Okay, problem 3. Notice this one, we do have a square root. If I were to try to do a u substitution, which is always our first bet, which we want to do, that will not get me anywhere because du is not in the problem. And I do notice there's a square root. I do notice it's not a trinomial, but I do notice that it is quadratic. So that leads me to believe that I'm going to do some completing the square. So on this one, this is a little bit different when I complete the square on this one. I can't complete the square with a negative sitting there. So please notice when I do this, I'm going to put a negative on the outside. That's going to make the plus 6x a minus 6x, because notice now if I factor that out, I will get the same thing with what I started with. Whoops, I forgot to leave myself a space. And there just happened to be nothing to put on the outside, but we'll take care of that in just a minute. Okay, so completing the square just like normal, we're going to divide by 2. We'll get negative 3. I will square that, and that will give me a positive 9. So I'm going to put a plus 9 on the outside. Well, usually we put a minus 9 on the outside to take care of it, but you'll notice if I were to distribute this negative, I really just introduced a negative 9 into the problem. So to undo that, I need to do plus 9. Okay, so now rewriting this problem into the problem, this is going to be negative x minus 3 squared plus 9. And I notice it's a good setup. I'm just going to reverse the order of this just to make sure it looks more like a problem we're used to. I'm going to put the 9 first. And now notice if you look at it, it's the exact setup for an arcsine problem. So we're going to go ahead and identify our parts for that. My u will be x minus 3. And on this one, in the other ones, arctan, the addition was commutative, subtraction is not, so we do have to have it as a squared minus u squared. So u will be x minus 3, du will be 1 dx, and a, the square root of 9, is 3. So now my arcsine formula, we don't do 1 over a on arcsine, we just simply do arcsine u over a, so x minus 3 over 3, and then plus c. Alrighty, number 4. Notice this one a little bit different is that I do have some endpoints that I'm going to have to take care of when I'm done. If you want to try to take the integral before dealing with the endpoints and then come back, that would be awesome. I do notice, again, this is going to be a completing the square problem and an inverse trig problem because I cannot do a u substitution on this one, and there is a squared in the problem. So I'm going to go ahead and get myself set up. I'm going to put it in order as well. So this is going to be negative x squared minus 3x. Leave myself a space. Nothing's going to go on the outside here. If I divide by 2, okay, that's all right. We'll get negative 3 halves. And then when I square negative 3 halves squared is going to be 9 fourths, positive 9 fourths. Okay, generally this would be, we'd subtract 9 fourths, but it really is minus 9 fourths already, so we're going to put plus 9 fourths. So if I rewrite this problem, I'm going to have 1 over the square root of negative x minus 3 squared plus 9 fourths. And again, I'm going to just rewrite that as 1 over the square root of 9 fourths minus x minus 3 squared. Okay, this is definitely an arcsine setup. So let me identify my parts. U will equal x minus 3. Du is just 1 dx, which was in my problem again at one point in time. And then a, the square root of 9 fourths, is 3 halves. So when I go to write this problem, again, there's no 1 over a in front of arcsine. It's going to be arcsine of u over a. And then instead of putting plus c, we need to evaluate it at 9 fourths and 3/2. And I don't know if I wrote this wrong, but this is turning out to be really icky. So let's just do this. Yes. Okay, so we have arc sine of 9/4 minus 3 over 3/2 minus arc sine of 3/2 minus 3 over 3/2. Okay, whew. All right, I'm really hoping that this is going to turn out okay here. All right, so 9/4, this would be the same thing as 12/4. So 9/4 minus 12/4 is going to be -3/4. And instead of dividing by 3/2, I'm going to multiply by the reciprocal of 3/2, which would be 2/3. So this is going to end up being arc sine. Okay, this is going to turn out okay here. -1/2. All right, and then minus arc sine of, let's see, 3/2 minus 3, that will be 6/2. So it's going to be -3/2 divided by 3/2. So here we go. That will be -3/2 divided by -3/2 is just -1. So we would like to find out, where does the sign equal -1/2 and where does the sign equal -1? Excuse me. All right, I do believe, let's see, -1/2. So where does the sign equal -1/2? I'm going to get out my fingers here. Sign is on the bottom, being 1/2 is going to be at the square root of, pi over 6. So where does let's see, where does my y value negative? That would be in either of these spots. So it's either going to be at 7 pi over 6 or 11 pi over 6, but I do believe arc sine, the range of arc sine is right here. Well, actually, you know what? Let's just, I'll finish the problem because I'm already here. So it's going to be 11 pi over 6, and then minus, where does the arc sine equal -1? Where does the y value equal -1? Down here at 3 pi over 2, or we could label it as -pi over 2. But anyway, we have an answer. But really, we could leave our answer just like that and we would be totally fine. So I think that's where I would stick, just to make sure that you're not making any errors. So hopefully now you can use completing the square to evaluate an inverse trig integral.